The next kind of chart we're going to talk about in our stats unit is a histogram. I know you guys have worked with histograms before, so this should be a refresher. A histogram is very similar to a dot plot. It shows how many of something out of a survey or an amount of numbers. It's quantitative data. And it looks like a bar graph. So a histogram is really a type of bar graph. And it displays how many times, which we call frequency, the data occurs. It's divided into equal intervals, and this is really important. So like last learning target, the major point I wanted you guys to be able to do is to work on your spacing with those number lines. A similar issue is going to happen here. We want equal intervals, and I'll show you more what I mean here. Okay, so below you'll see an example of a histogram. This histogram shows scores on a math test. So you're going to notice there is a horizontal axis and a vertical axis. So for letter A, it says, look at the histogram, which axis indicates the frequency. So over here on the left, you're going to see this word frequency. Now, every histogram you ever make, the y-axis will always be frequency. So that will always be what you label the y-axis in every data set. And frequency basically means how many times the data on the horizontal axis is showing. So on B, what does the horizontal axis indicate? In this particular graph, the horizontal axis indicates test scores. Okay. And letter C, how is it organized? Well, it's organized by these little intervals. So see how we've got 60 to 69, 70 to 79, 80 to 89, and 90 to 99? These are intervals. I'm not just saying the amount of scores that are 60, the amount of scores that are 62. I'm saying that from the range of 60 to 69, we've got 3 students that scored in that range. Okay? So the horizontal axis is organized in intervals. Okay, and that's an interval of 10. Even though it's from 60 to 69, if you label them all out, 60, 61, 62, 63, I'm going to write all of these out. If we count them, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 60 to 69 is an interval of 10. Even though it looks like the difference between 69 and 60, I've actually got 10 values in that interval. That's going to become really important that you understand that, okay, going forward, because you'll have to create your own intervals, right? So letter D, E, F, and G are asking you questions about reading the graph. So how many scores in the interval 60 to 69? Well, I already kind of started that. If I draw my line over, it's between 2 and 4, so that means there's 3. How many scores in the next interval, 70 to 79? Well, that would be 9 when I draw the line over. How many scores in the interval 80 to 89? That would be 12. It goes up to here at 12. And then how many scores from 90 to 99? That is 7. So this is what this histogram means, and this is how we read it and organize it in our minds. Okay? That's the easy part, is being able to read the histogram. Okay? Histogram shows some statistical information that we can get from the data. So what information can you tell about a data set by looking at a histogram? Well, different than a dot plot shows individual values. A histogram shows the range. So you can determine data points in a range. For example, in this histogram, we can determine we've got 3 data points within 60 to 69. Okay, we don't know exactly what values they were. It could be 3 61s. It could be a 61, 64, 67. We can't get that information from a histogram, but we can get a general idea of what the ranges were. Okay, what statistical information cannot be determined by looking at a histogram? Well, what I just said, we cannot determine individual values. by looking at it is what I mean. Okay, the data set might have them, like when you're given a data set, but if I just look at this histogram on its own, I don't know how many people scored a 61. I can't know that unless I had the original data set. Number 2 is asking how many total test scores were collected. So if I collected 3 scores here, I collected 9 scores here, 12 scores here, and 7 scores here, then all I have to do is add 3 plus 9 plus 12 plus 7 will give me my total scores. 3 plus 9 plus 12 plus 7 is 31, so that means there were 31 total test scores in the data set. Okay, so there's the basics of reading a histogram. Okay, that's page 1. So turn your page to page 2, and we're going to talk about how we create a histogram. So example 1 says create a frequency table from the data, and then use that table to create a histogram. So here I've got the ages of 100 U.S. senators at the start of Congress in 2011. So 7 years ago, we had 100 senators, and this was their ages. Okay? And we want to be able to create a histogram from this data set. The first thing we want to do before we go right into the histogram is figure out our intervals and figure out how to count how many are in each interval. So the first thing I want to do is figure out how big my intervals should be. In the last example, my intervals were intervals of 10. And the way you can figure this out is by counting how many data points we have and then taking the square root of that number. Okay, so right now they tell me that the total data points is 100. So what I'm going to do is I'm going to write out the total is 100, and then I'm going to take the square root of 100. Now that's really fortunate, it's a perfect square, so I know the square root of 100 is 10. So this means that my intervals are going to be in intervals of 10. With that, that means that I'm going to have an interval of like 0 to 9. And then 10 to 19. Because remember last time I talked about this interval in the beginning was also intervals of 10, and the way I knew that was by writing all these out. I don't know where those went. They must have gotten erased, but I wrote them all out, and I told you that even though it says 60 to 69 right here, that's actually 10 values. So when you ever have an interval of 10, you're actually going to have a difference of 9. If you have an interval of 8, it's a difference of 7, and so forth. So in order to figure out what my first interval is going to be, it's not always going to start at 0. I'm going to look at my lowest number here, 39, and then I'm going to look at my highest number here at 86. Okay, now I want to make sure that I include every value with an interval of 10. You could do this 2 different ways. You could start at 39 and then go to 48. You could do that, but that's really kind of harder math. I know that's a difference of 9, but it doesn't seem very obvious it's a difference of 9. So what I'm going to do instead is I'm going to do 30 to 39. And again, if you did 39 to 48 or some other interval of 10, as long as 39 is included, then you're fine. So you might get different answers in my answer keys as long as your intervals are all equal. So my first interval is 30 to 39. That means my next interval will be 40 to 49. Then 50 to 59, 60 to 69. And I'm going to stop here and take a look back at my data set. I noticed that my highest number is 86, so I need to make my interval go up to 86. So I know my interval has to go to 86. So now my next one is 70 to 79. Still not 86, but when I do this interval, 80 to 89, that's including all the values. So I'm checking that all my intervals include all the values they give me. It goes from 39 to 86 is included in this interval, and my intervals are equal. Okay, this is the hardest part for sure of this learning target, is creating these intervals. Because now comes the easy part. Now we're going to count how many times we get numbers between 30 and 39. And I like to do something called tallying so I don't make a mistake. So tallying means I'm going to go ahead and count all the numbers between 30 and 39. So I've got 1, 2 here, and I cross them off, 1, 2. 42 and 44 also between, 42 and 44 are not in that interval, so I only have a tally of 2 that are in that interval, 39 and 39. 40 to 49, I'm using a different color to show you this tally. 40 to 49, I have 1, 2, 3, 4, 5. I count by 5, so 1, 2, 3, 4, 5. 47, 48, 49, 49, and 49. There's another 5. And then I look at the number 50. 50 doesn't fit in this interval. So that means I have 10 here based on my tallies. Okay, you could just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But with larger data sets, sometimes you might miss one. Okay, I'm going to go ahead and pause and fill this in so I don't waste your time. If you want to, you can pause and count yourself and see if it matches. I just don't want to spend the video counting and make the video extra long. Okay, so after you're done counting all of these data points, you should get 30 in the 50 to 59 range. You should get 37 in the 60 to 69 range, which is a lot. If you might have miscounted here because that's a large amount of data points. You should get 18 between 70 and 79. You should get 3 between 80 and 89. Okay, cool. So we've counted. We have our intervals. That's step 1. The next step then is to look at our grid and create a nice set of scale like we did in the dot plot. So the bottom part is pretty easy. The bottom part is I'm going to make these little diagonal lines for 6 intervals. So there's 1, 2, 3, 4, 5, and 6. You might have to make this a little bit longer here, which is okay. That is not your bell, that's the bell in the video, so do not leave. Okay, so I've made my 6 little intervals and I'm going to label them. Okay, and you might have to turn your paper to do this and write sideways. So the first one is 30 to 39, then 40 to 49, 50 to 59, 60 to 69, 70 to 79, and 80 to 89. Those are your 6 intervals, okay? So I'm going to go ahead and erase this little extra part. Okay, so there's your 6 intervals down at the bottom. On the right, this is where your dot plot skills come into play. Because on the right, I want these nice even intervals. Now see how they've already given you lines here? That's really nice. So if frequency is always done by like 1, 2, 3, 4, 5, 6, like this, right? But if I go ahead and label this, I've got a problem. Because my frequencies go way past the number 9. So I can't do 1 through 9, okay? I could try to go by 2s, 2, 4, 6, 8, and etc. But I have another problem. This still doesn't go all the way up to 37. So the next likely interval that you probably would think about is 5s. Okay, that's where my brain goes. So now I'm going to go 5, 10, 15, 20, 25, 30, 35, 40. And I'm going to stop there because I noticed that 37 is my highest value, so I'm not going to go above 40. Now, all you have to do is draw bars for each interval. So the interval of 30 to 39 is going to be 2, so estimate 2. 2 is about right there, so I'm going to make a bar at 2 and fill it in, okay? For 40 to 49, now I've got 10, so I'm going to make a bar at 10. Now notice that your bars have to touch, which is different than a bargram. In a histogram, the bars must touch. Okay? And then you're just going to fill out the rest of the bars. Okay, the next interval goes to 30. Color it in. You just need to shade here. You don't need to fully color that in. 60 to 69 has 37. Again, you'll have to estimate. There's about 37. Shade it in. 70 to 79 is 18. So that's a little bit higher up. Make sure you're estimating correctly. Shade that in. And then 80 to 89 is 3. And that goes right here. 3. All right. So there's your histogram. Okay. Oh, I forgot this part. Sorry. So the other part here is check that the sum of the frequencies is 100. So all of that means is that add up what you get. 2 plus 10 plus 30 plus 37 plus 18 plus 3 gives you 100. And it does in this example. Okay. The last thing here, describe the shape of distribution. That word distribution means where it skews. Is it skewed left, skewed right, or is it symmetric? This is definitely symmetric. Okay. Which means that we've got a good average in the middle. Sorry, got those bells, guys. We have a good average in the middle, meaning we don't have a lot at one really big end of the data set, right? We don't have one senator who's like 12, right? They're all in a pretty generally average range. Okay. Let's take a look at another example where I don't give you much structure. Here in this example, I just give you data points, and you have to go ahead and make your frequency table and make your histogram. All right, so I'm going to go ahead and make a little table here. Okay, this is going to be my interval. This is going to be my frequency. So the first thing I'm going to do is count the number of data points I have. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I've got a total of 15 data points. So to help me figure out my intervals, I'm going to take the square root of 15. Now that's unfortunate, it's not a perfect square, but I've got a calculator to help me. So on my calculator, I'm going to go second square root symbol, and I'm going to type in 15. I'm going to get a decimal. It's 3.8, so I'm going to round that up to about 4. So the square root of 15 is about 4. So that means my intervals are going to be 4 apart. Okay. My lowest number in my data set is, let's see here, I've got a low number of 63. So 63 is my lowest number, and my highest number is 79. Okay. Now, I like to start on 0s or 5 numbers. So if my interval is 4 and I want to start at 60, 60, 61, 62, 63, that's 4 data points. So again, I'm going from 60 to 63. And like I've said a few times in this lesson, if your interval is 4, it's going to be a difference of 3. If your interval is 5, it's a difference of 4. So that's the part that you're going to have to be really careful on. You don't want to go 60 to 64. Okay. Now, you could have started at 61, you could have started at 62. As long as they're 4 apart and 63 is included, you're fine. Okay? So then my next interval, I'm going to go until I get to 79. So then 64 to 67, then 68 to 71, 72 to 75, 76 to 79. And now I've got all of my values within those intervals, and all my intervals are evenly spaced. Okay. Now I'm going to count how many of these I have in each interval. So I'm going to go through this list, and notice they're not in the right order. So this is where a tally becomes really helpful. So 60 to 63, there's 63. I only have 1. So frequency of 1. 64 to 67, I've got a 65, so there's 1, and that's all. So there's another 1 for frequency. 68 to 71 is 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. So that's 5 right here. 72 to 75, I've got 1, 2, 3, 4. 5, 6. So I've got 6 in that interval, and then the leftover 79 and 76 is 2. So I've counted all my data points in those intervals. Now all I have to do is make my histogram. I've got a nice 1 through 6 here, so I think I'm safe doing 1, 2, 3, 4, 5, and 6. That works out pretty well. And then like before, I'm going to draw these little diagonal lines. I have 5 intervals, so 1, 2, 3, 4, and that gives me 5 slots. So I'm going to go ahead and label those. 60 to 63, 64 to 67, 68 to 71, 72 to 75, and 76 to 79. And now the easy part of just drawing my bars to where they need to be and making sure they're touching. So this interval goes to 1, shade. This interval also goes to 1, shade. This interval goes all the way up to 5. This interval goes all the way up to 6. And then your last interval goes up to 2. So this should be what your histogram looks like. Okay? All right, the next example I'd like you to try on your own. I've already given you a nice frequency table, so you don't have to draw that on your own. And I've given you a grid to make your histogram. Now, the additional thing you'll have to do on this when it's blank completely, you've got to remember to label your axis. So let's read this problem. I'm going to get you started. The Arlington High School varsity boys basketball team had an excellent season, compiling a record of 15-5. The total points scored by the team for each of their 20 games are listed below in order of which the games were played. So game 1, they scored 676, game 2, 55, etc. So when I label my axis for this, remember that this side is always frequency in a histogram, every time. Now the bottom is what the data points represent. In this particular data set, the data points represent the points scored. So I'm going to label this the points scored. Now on your own, you're going to go ahead and figure out your interval, and you're going to go ahead and plot how many points go in those intervals. Okay, so I'm going to pause and see if you can do this on your own. Okay, this is what I'm really grading you on, are these intervals and being able to figure them out. So be sure you can do this part. Okay, so I'm going to go ahead and pause. So this is what I came up with for my histogram. I noticed that there were a total of 20 data points, and the square root of 20 is around 4.8. So I basically rounded that up to 5. So I had my data points going through 5. I did start the first one at 45 to 50 instead of 46 to 50. I did that. You could do that either way. You could start at 45 and go to 49. Either way, it works. I've got that extra data point in there, which I probably shouldn't have included, and I'm just now realizing that. So technically this guy should have been 45 to 49 if I wanted to do that correctly, but I did not. If you want to come check to see if your intervals are fine, please come ask me. Your intervals might look different than mine. They just have to be even and equal. Okay. Also notice here when I did my labeling, I tried to use the whole grid. Don't do 1, 2, 1, 2, 3, 4, 5, because you're not using the whole grid and you're leaving a lot of blank space. I did leave blank space here because the grid was a little bit too big, and so I X'd those out. And if I tried to go by 2s, I would have run out of room. So a lot of this takes some experimenting. You know, you might try to label it and it not work. You might try and label it and it does work. You have to kind of experiment, which is why we use pencil. Okay. The last thing I want to talk about is looking at a graph and answering some questions. So here I already give you a histogram, and the data is talking about, again, the number of students and how much they score on a pre-calculus exam. So the first question says, how many students scored in the 75 to 79 point range? Well, that's this point right here. And if I scroll over, I can see that that is a score of 10. So 10 students scored in that range. The next question is asking, students do not pass the quiz if they receive lower than a 70. So how many students did not pass? So we're looking for all of the ranges that are below 70 and do not include 70. So when I look at my ranges, this is definitely included because 60 to 64 is not passing. This is included, 65 to 69 is not passing. However, I can't count this interval because 70 is included. So I really am only looking at these two bars right here. This guy, this one right here, and this one right here. So when I look over, that's at 1, 2. So that has 2 students that scored there. And this one hits right at 5. So I've got 5 students there, which gives me a total of 7 students that did not pass this quiz. How many students total took the quiz? So we talked about this earlier in Learning Target, but what I like to do is I like to go ahead and label how many students each of these bars represent. So if I take this bar and kind of scroll it over, that's 5, 6, 7, 8. So you kind of have to be careful when reading these because they're not always labeled. Okay, you can use a ruler. That always is helpful. Then I've already counted this as 10. The 80 to 84, it scrolls over to 1, 2, so that's 22. This bar is nice. It hits at 25 exactly. This bar hits at, I believe that's 16. Again, I would, a ruler would be helpful here. And then 95 to 100, that hits at 3. It's the same as the 2. Oh, wait. Yes. No, different than 2. 2 is different than 3. That hits at 3, that one hits at 2. And you can kind of tell because one is bigger than the other, but again, a ruler is really helpful here. So now all I have to do is add all of those up. So I'm going to go to my calculator, and I'm going to go ahead and just type all of those out. So 2 plus 5 plus 8 plus 10 plus 22 plus 25 plus 16, and then plus 3. I get 91. And I noticed that 91 is an answer choice, so I'm assuming I did that correctly. Okay. And then the last question is a really important question in this learning target. It says that 22 students scored in the 80 to 84 range on this test. So I'm going to stop and just kind of go to my graph and look at where that is. That's right here, 80 to 84, so it's this one. Does the histogram provide us with enough information to conclude that a student must have scored 82 on this test? Explain your thinking. So it's saying that I've got 22 students in this range. So 22 students between 80 and 84. Now, it's asking, can we basically guarantee a kid got an 82? And the thing with a histogram is we can't guarantee that. Since this is a range, you could suppose a lot of things. You could say that all of those 22 kids scored 80. All of those 22 kids scored 81, and no one scored an 82. You don't exactly know. You can't just assume that there's all of those values in that range, because a value can fall in that range and it not be included in that interval. If we go back to our previous data set, when I look at this histogram, the number 54 never shows up here. However, 54 falls into this range right here, but it doesn't show that in my histogram that 54 wasn't a data point. So the answer to this question is no. You absolutely cannot, because a histogram does not show individual numbers, individual data points. If this problem had given me all of the scores, I could go look at the scores and see that an 82 is there, but just the graph alone will be enough. Okay? So, key points in this learning target: making your intervals. I'm not always going to give them to you, and they have to be equal. Okay. Second of all, making sure your bars touch and labeling your axis of your histogram. Okay. Good luck. When you're checking your answers, make sure you're checking for intervals, and if my intervals don't match yours, just come ask me and I can let you know if they work. We can all pick different intervals and it still work out. Okay. Good luck.